Today we're going to take a look at solving some quadratic word problems, okay? Or rather, max and min word problems. Remember, when your parabola is upside down, this is a max point, as it's the highest. And when your quadratic is right side up, or opening upward, this point here is a minimum point, as it's the lowest. The steps are there at the table in at the top. Step number 1, determine what x represents and determine what y represents, and label your axes. So what are your variables? Okay, you have to determine that and then label your axes. Find the axis of symmetry. Okay, this represents half of your x-axis or your window. And remember, the equation for the axis of symmetry, we'll put this on the side as a reminder, is x equals negative b over 2a. Now, standard form we covered on the first day, and that was f of x equals ax squared plus bx plus c, or y equals ax squared plus bx plus c. Our vertex form is going to be f of x equals a times x minus h squared plus k. And remember, hk is the vertex. And the vertex is your max or min point or turning point of the parabola. Step number 3, find the vertex either graphically, okay, so you can graph it so you can see it, or calculate the value on the calculator, and I'll go over how to do that. And then by looking at the table, or we can do it algebraically. So if it states a method, you have to use the method, but if not, you can choose your method. And then number 4, a sketch of a graph includes a scale, okay, labels, and any points used to answer your questions. So let's take a look at number 1. The height in feet of a golf ball hit into the air is given by the function h of t is equal to negative 16t squared plus 64t, where t is the number of seconds elapsed since the ball was hit. Okay, part A, graph it. And if you think about a golf ball being hit, okay, the golf ball's got to go up and then it's got to come down. So kind of picture what it's going to look like before you graph. And remember, on the calculator when you type this in, this would be equal to, h of t is your y, negative 16x squared plus 64x. So our x-axis is the t, or time. So let's label our x as time, and in seconds. And the h of t, or y, h is our height, and that's in feet. So the height, our y-axis, is dependent on the x-axis, or the amount of time that has passed since in this case, since the ball was hit. Okay, part 1. Use the axis of symmetry formula to find the x-axis scale. Okay, so axis of symmetry is x equals negative b over 2a. So we have an a value of negative 16. And as the a goes first, ax squared plus bx plus c. So a is negative 16, and the b value is 64. So our axis of symmetry is x equals negative b, so negative 64, over 2 times negative 16. So it'll be negative 64 over negative 32, which equals a positive 2. So our axis of symmetry is the equation x equals 2. So let's put a dotted line there where our axis of symmetry would be. So the vertex, remember, falls on the axis of symmetry. And since our vertex Okay, it was right in the center of our parabola. Is at 2, we know we at least need to go out to the 4. Okay, so the scale, or our axes, our x-axis goes from 0 to 5. Find the vertex to get the y-axis scale. How high do we need to go? And I realize it's there, and this states that we're going to go as high as 64. But let's actually calculate the vertex, that highest or maximum point, so that we know it does indeed need to go up to 64. So if I know x is 2, okay, I'm now going to plug it into the function and do negative 16 times 2 squared plus 64 times 2. So I'm evaluating that function. 2 squared is 4, and then 4 times negative 16 is negative 64, and then 2 times 4 is 128. So when you add those two together, you do get 64. So our vertex is the point 264. So let's mark that point, 264, right there. Create a table of values for the rest of the points. So using the table, we know we need to plot 7 points. So I'm actually going to use function notation. So this would be t and then h of t. We know the vertex is going to be right in the middle. So 264 is here. Okay, and then I'm going to work my way out. So typing it into the calculator, y equals negative 16x squared plus 64x. Second graph. Or second, I want to see the graph first. And then I'll go to the table. You notice we can't see much of the graph. And when you look to the right, we've chosen quadrant 1. And we will be graphing in quadrant 1 because on the x-axis, we don't have a negative unit in time and a negative unit in height. So that limits us to that first quadrant. So if you go to the window, you can change your window to be in the first quadrant. So let's change the lowest x value to be 0 and our highest to 5. And then we'll use a scale of 1, the minimum y value of 0, and let's do the highest of, instead of 64, let's do 70, even though we know the maximum point's at 64. Now we can see a nice curve. Okay, second table, we're looking for that 264 in the middle. Okay, we don't need the negative 80, so we'll take those points from the x values of 0 to 4. So 2, 1, 3, and it's symmetrical, so 48, 48, 0, 0, 4, 0. So let's plot these points. 0, 0, 148. 264 is already graphed because that's the vertex. 348 and 4, 0. So now let's draw our curve. So the ball goes up. So on the left side of that vertex, the left side of that axis of symmetry, we have it increasing, and then the right side is decreasing. Find the maximum height. Well, the maximum height here is 64 feet. How long does it take for the ball to reach its maximum height? So at 0 seconds, we haven't hit it yet. At 1 second, it's at 48 feet. To reach its highest, it's right here at the vertex 264. So how long, that's time, that would be 2 seconds. Part D, now I don't want to move it up too far because I want to be able to see this curve. How long does it take for the ball to hit the ground? So here at 0 seconds on the x-axis, it hasn't been hit yet. So it gets hit, and then it comes up, and then it's going to hit the ground here. So how long does it take? It takes 4 seconds. For how many seconds is the ball more than 48 feet up in the air? So I'm going to take a highlighter, and highlight that part of the curve where the ball is more than 48 feet. So here's 48, so it's right here. So more, we go down, so 1, go down. So E for how many seconds? So for 2 seconds. And then last, determine all values of T for which the height is greater than 48. So that's this section right here that I just blocked off. At 1 second, okay, it was exactly 48, and at 3 seconds it's exactly, so it's between the 1 and the 3, but not including. So think about shading that on the number line. So it's all those values between, and the inequality for between would be, again, from 1 less than T, which is our time, less than 3. We don't have the equal to lines on the inequality symbols because it's not including. Okay, on the back side, a model rocket is fired upward from the ground with an initial velocity of 88 feet per second. Its height in feet above the ground as a function of time is given by h of t equals negative 16t squared plus 88t. Now the rocket, if you think about it, it's going up and it's coming down. Okay, so I'm going to draw a little picture here. The rocket's going up, it's coming down. And we know too, because of that negative sign, the parabola is going to be upside down. Okay, so we have height, again, for our y, and then time. Okay, so our y to the right is our h of t, which means our height in feet above the ground, just as it says in the word problem. And then x, you can think about typing this in our calculator, it would be y equals negative 16x squared plus 88x. So x is our t, or our time in seconds. Part A, when does the maximum, or when does the rocket reach its maximum height? So that's right here. And when is time? So when I go straight down here, that's what I'm looking for. This point has an x value and a y value. That's the maximum point. So I want to find the x value of the vertex. Okay? And I drew the line like the dotted line, okay, of our axis of symmetry. It'll always go through that max or min point. So we use the axis of symmetry equation to find x. So back over here, we have an a value of negative 16 and a b value of 88. Because it goes a in front of the x squared, and then b, and then c last. So our c value is 0. So substituting in, we're going to have negative 88 over 2 times negative 16. So negative 88 over negative 32 gives me an x or a t value for time. 88 divided by 32 is 2.75. And we'll label that when, so 2.5 seconds. Okay? What is the height that the rocket reaches? The maximum height, the highest. So that would be going across the y value that goes with that. So now we know what x is. We can take that x value, or that time value of 2.75, and plug it into the function. So to evaluate, it would be negative 16 times 2.75 squared plus 88 times 2.75. Okay, doing the calculations, doing the math, we're going to end up with, let's go to the calculator, 2.75 squared, 7.5625 times negative 16 is negative 121. And then 88 times 2.75 is 242, which if you notice is double 121, so subtract, and we get 121 feet. And then, so x was our time, and y is the height. When will the rocket hit the ground? Okay, so just to trace in yellow, the rocket's going up and it's hitting the ground right here. So that is our route, okay? But if it took, okay, 2.75 seconds to go up, we can assume it's going to take 2.75 seconds to go down. So multiplying 2.75 times 2, the rocket will hit the ground at 5.5 seconds. And then the note here, which I didn't notice, says this is really asking at what time the height is at 0, or what is the value when h of t equals 0. So we actually, if we did 0 equals negative 16t squared plus 88t, that's actually solving a quadratic, okay? And we'll get into solving a quadratic equation on the next day, so tomorrow, or the next class, okay? So next class we'll learn how to solve that, but for now we'll just use the graph. Number 2, and then I'll actually show you some things on the calculator with number 2. Future projection for sales of a company are modeled by the equation 2x squared minus 24x plus 100. Where S represents sales in thousands of dollars and X represents months in the future. Over the next year, what is the minimum amount of sales expected for this model? So the minimum amount of sales, okay, let's take a look at what this curve looks like. So y equals 2x squared, so it's a positive x squared, so that should give you a hint if it's right side up or upside down, minus 24x plus 100 graph. Okay, we can see part of it, but let's look to change our window for the x-axis. So again, we're looking at sales, okay, for a company in thousands of dollars. So let's change the, say, to 50,000 graph. Oh, we can't even see any of it. And that's because our sales is our y-axis. Let's go back to window. The x, it represents number of months. So let's change that to 12 months in a year. And let's change the max to 50,000. 50,000. Okay, a couple of things here that I made an error with. I left the window at 12. You can see the axes, or the scale is counting over 12. But it said that S represents the sales in thousands. So when you go to the window, I didn't want to put in 50,000. I just wanted to put in, so I left the X as 12 for the months. But I just wanted to leave the Y max as 50 because it was in terms of thousands of dollars. Okay, so there's our picture. Our graph is opening upward. Okay, it's a happy parabola as the x squared is positive. So let's take and sketch that. We can calculate our intercept. Okay, but here's our parabola. Okay, what is the minimum amount of sales? Again, X was the number of months. And our Y is our sales. Okay, and in how many months? So if we're looking at this vertex, we're going to calculate to determine what that X value is. We're going to do the axis of symmetry because the minimum is a vertex. And to calculate the vertex, we do axis of symmetry. So X equals negative B over 2A. And here our A is 2, our B is negative 24, and our C is 100. So plugging it in, a negative of a negative 24 over 2 times 2. So we end up with positive 24 over 4 is 6. So in 6 months, the minimum will occur. So what we just found is the 6 of the vertex. Okay? Now we need to find what the expected sales is. Okay? So what's our Y value to go along with it? So now that we know X, we just simply plug it into the function. So 2 times 6 squared minus 24 times 6 plus 100. So this is 36. 2 times 36 minus 24 times 6. Well, 6 times 4 is 24, carry the 2. So 144 plus 100. So we have 72 minus 144 plus 100. So 72 minus 144 is negative 72, plus the 100 is 28. So the minimum amount of sales is expected to be not 28, because that was in terms of thousands, but $28,000.